Here's a quick puzzle that was pulled from the Polish Junior Math Olympiad. Let's start off by taking a 9x9 square grid. The puzzle asks us to find a way in which we can cover the entire grid using only tiles of size 1x5 and 1x6. And if the puzzle has no solution, then prove that it's impossible. If we try to just give the puzzle a shot, we'll quickly find that it's not as easy as it may seem. So, does this mean that the puzzle has no solution then? Here's your chance to pause the video if you'd like to give it a try before we go through it together. I encourage you to keep playing around with it and see if you can gather any useful insight. Alright, first things first. Given that our grid is 9 squares high by 9 squares wide, then that means we have exactly 81 squares to cover. And since we're only allowed to use tiles of size 1x5 and 1x6 to do so, then the number of tiles used must satisfy the following equation, where x is the number of red tiles and y is the number of blue tiles. This here is just a simple linear Diophantine equation, and it's not all that difficult to find all of its natural number solutions. In fact, there are only 3 of them, which you can verify yourself by using the Euclidean algorithm or a bit of trial and error. Alright, cool. How about we just try to solve the puzzle again? At least this time we know how many of each tile is needed to cover all the squares. Okay, that's not good. How about we try using one of the other equations this time? No luck again. Well, maybe the equation isn't the issue and we're just going about it the wrong way. In any case, let's not waste too much time here and do a bit more inspecting. If we go back to our equation and its solutions, we can see that the minimum number of tiles needed to cover 81 squares is 14. And this should make sense, since anything less than 14 will only be able to cover 78 squares at most. Alright, great. But how is this supposed to help us solve the puzzle? Well, since we know the tiles can only be placed horizontally or vertically, then knowing this fact tells us that at least 7 of them must be placed horizontally, or at least 7 of them must be placed vertically. And it doesn't matter which one we assume to be true here, we'll end up reaching the same conclusion either way. So without loss of generality, let's go ahead and assume that at least 7 of our tiles are placed horizontally. And for now, let's say the count is exactly 7, just so we can have some sort of visual to work with. So maybe something like this, for example. One thing to notice right off the bat is that there's no way for us to fit more than 1 horizontal tile in each row, no matter where along the row the tile is placed and no matter which tile we choose to go with. And this should make sense, since there are only 9 squares in each row. And so, naturally, this should also imply that each column will only be able to fit 1 vertical tile at most. Another thing to notice here is that in each of the rows containing a tile, the middle square in column number 5 is always covered. And this is actually unavoidable, no matter where each tile is placed and no matter which type of tile you go with. And since we have 7 rows occupied by 7 horizontal tiles, then we'll always end up with 2 empty squares along the middle column. Now, there's clearly no way for us to cover these empty squares using vertical tiles. So, in order for us to make any more progress, we have no choice but to occupy the 2 remaining rows with horizontal tiles as well, as this is the only way to make sure those pesky middle squares are covered. Okay, now that every row contains a horizontal tile, and since we know we can't fit more than 1 of them per row, then from here on out we'll only be able to place vertical tiles if we want any chance of solving the puzzle. Now, let's push everything towards the left and make them all red tiles in order to give us some space to work with. Similarly to what we noticed earlier with horizontal tiles, not only does each column fit a maximum of 1 vertical tile, but no matter where this vertical tile is placed and which type of tile you use, notice that the square in the 5th row, or the middle row, will always be covered. And since the middle row is already occupied by a horizontal tile, then we know it will have either 3 or 4 empty squares along it, which means that at most we'll only be able to place 4 more vertical tiles onto our grid. And that's a problem for us. See, we just showed that the board can only fit a maximum of 9 horizontal tiles and 4 vertical ones. Or, 9 vertical tiles and 4 horizontal ones. Which, when added together, comes out to 13 tiles in total. But earlier we saw that the minimum number of tiles needed to cover 81 squares was 14, hence a contradiction. And there we go. This proves that the puzzle is impossible to solve. Here's a question for you. Would the puzzle still be impossible if instead we were using tiles of size 1x4 and 1x6? Let me know what you think in the comments below. And if you enjoyed the video, please don't forget to leave a like. It really helps the channel out. And while you're at it, subscribe to stay tuned for the many more math puzzles coming very soon.